So hello everyone, welcome to the lecture 2 of our tree playlist. So in the last video we discussed regarding the basic terminologies of tree. Now in this video I will discuss regarding binary tree and its types. Okay, so first now let me create a tree. Okay, so this is a binary tree. The word itself, binary, that is bi, that means two. Each node here in this tree will have two children. Okay, either two children or one children or zero children, but maximum two children. This node, it has two children, which are these, left and right. Just like I told in the last lecture, that is lecture 1, regarding the two pointers, left pointer and right pointer. So that denotes the left child and right child in this binary tree. For this node it has two children, this and this, but for this node, which is a leaf node, it doesn't have any child. Okay, and for similarly for this node and other nodes as well. Okay, so this is a binary tree. And now as you know, this is a root of the binary tree. These are the leaves and other nodes are the intermediate nodes. Okay, now one important concept of tree is to find the height of tree. Okay, to find how the way we find height of tree we will discuss further, but till now we'll discuss what exactly height of tree mean. Okay, so here in binary tree we say that is the root node has maximum height. Okay, and the second pointer is the leaf node has height 0. Okay, so using these two characteristics we'll find the height of this tree. Okay, so now this we in this tree we go level wise. That is, if you can see, this is level 1, that is we can say level 0, and another level, that is level 1, we find these two. This is level wise we go. Okay, so you can see these leaves. Okay, the last level is always have all the leaves. Okay, now what is the height here? Height here is 0, and similarly as we go up, the height is calculated from bottom to top. Okay, as we go up, the height increases by 1. This node has height 1. Okay, now if we go one more up, level 2, and above it we have the root, that is 3. So we can say that this tree has height of 3, 0, 1, 2, 3, or we can say the number of levels. Okay, number of levels is the number of levels minus 1 is the height. So height equals to 0. We will discuss later on how we find the height of a tree using various traversals. Till now you only need to know about these two properties, that root node has maximum height and leaf node has height equals to 0, and this is the way I told you in a very basic way, that how to get to know the height of the tree by seeing the tree. Okay, now another topic is depth of tree. Same as the height of tree, this is also a very important concept. Before learning this concept, that what actually it is, similarly as I told these two properties, for the depth of tree I will also tell you that here in depth of tree, the root node has depth equals to 0, and the leaf node at last level has maximum depth. Okay, now let me explain this two properties, that the root node has depth equal to 0 and leaf node at last level has maximum depth. So this is a root node, it has depth equals to 0. Okay, 0. Now as I move further in the next level, I increase this by 1, depth is 1. Again similarly I'll do it for all the levels 2 and 3. You can see that this is also a leaf node, but it has depth of 3, but these are also the leaf nodes which has depth of, sorry, this has depth of 2, while here we saw that the root node has the depth of 0, and as we go down in the level wise, we can see that the depth of all the nodes at that particular level increases. Here we see that this is also a leaf node, but it has a depth of 2, whereas the other leaf node that is on the more further below levels that have the depth of 3. As I told that the leaf node at last level has the maximum depth. We can see that this is the last level, and all the leaf nodes at this last level have the maximum depth, that is 3. Okay, so till now we discussed regarding the height and depth of 3. Now we'll discuss regarding the types of binary tree. Types of binary tree. Here we will discuss only 3 types of binary tree, which are the most important and mostly asked. The first is complete binary tree. Complete binary tree. So as the definition says, that all the levels are filled except the last level, which is filled from left to right. Now we have the 3 examples of trees. Now let us find out which is a complete binary tree and which is not. In the first example, to determine, we just segregate all the nodes level wise. Okay. Now the definition says that all the levels are filled. That is, forget about the last level. Okay, forget about this level. All the level below up, we see that whether all the nodes are present or not. That is the first root node should have 2 nodes. Yes, it have. Then this node should have 2 nodes. Yes, it has. And what about this? It should also have 2 nodes. Yes, it has. So we can see that all the 3 levels, 0, 1, 2 level, are filled. And it says that the last node, except the last node, that last node may or may not be filled, but it should be filled from left to right. That is, it should be filled from this direction, from left to right. We can see that these nodes are filled. Okay, so we can see that yes, it is a complete binary tree. If like for example, it would have been like this, then no, in that case it would not be a complete binary tree, because if it should have nodes. To have this node, it should have nodes before like this. Then I can say that it is a complete binary tree, but it should follow this rule that the node should be filled from left to right. Now in the third example, we again segregate the nodes level wise, and first we will see that whether all the nodes except the last level, all the levels except the last level are filled or not. We can see that this root node should have 2 nodes. It is having a 2 node. And what about this? It is also having 2 nodes, but this node is not having 2 nodes, and this is not the last level. So no, it is not a complete binary tree. Now the third example, we again segregate nodes level wise. Okay, now we'll check whether the all levels except the last level is filled or not. It should have 2 nodes. It is having 2 nodes. This is also having two nodes. This is also having two nodes. This is also having two nodes, but this is not having two nodes. And what? And this is also not the last level. So no, it is also not a complete binary tree. So you can solve many more examples to clarify whether which tree is a complete binary tree or not. And for your better understanding, you can solve. You can make any random tree by yourself and identify. Now our second type of binary tree is a full or strict binary tree. The definition says that each node should have either 0 or 2 children. Okay. Now let us understand by seeing the examples. We have 3 examples. In the first example, let us see. We again see all the nodes individually. Okay. This node. Each node should have either 0 or 2. It is having 2 nodes. Okay, that is perfect. What about this node? It is also having 2 nodes. Good. This node is having 0 nodes. Okay, that is also acceptable. This node having 0 child. Okay, acceptable. This node, it is also having 0 child. Okay, so we can say this is a full or strict binary tree. Okay. Now the second example, we can see that this node, it is having two child. Okay. This node having 2 child. These 2 nodes having 0 child. What about this node? This node is having only 1 child, but that is not the definition says. It says either it should have 0 or 2. So no, this is not a full or strict binary tree. Now the third example, we'll go from top to bottom node wise. This node is having 2 nodes. Okay. This node is having 2 nodes. Okay. This node is having 2 nodes. Acceptable. This node is having 0 nodes. Okay, that is also acceptable. This node is having 2 nodes. Okay. This node is having 0 nodes. Okay. What about this node? 2 nodes, and these 2 are leaf nodes having 0 childs. Okay. So we can say that this is a full or strict binary tree. You can solve more questions by randomly making tree by yourself by better understanding. Okay, the third type of binary tree is perfect binary tree. The definition says that all levels are full and all leaf nodes are on the same level. Okay, so this is a very easy type of binary tree to identify. We can see that every node should have 2 children. Okay, another hint to identify that, check if any node is not a leaf node, then it should have 2 nodes. That's it. And all the leaf nodes should be at the same level. So we can say this is a binary tree. Now in this, we can say this node is it is a leaf node, but not at the last level, and it is not having 2 nodes. So we can simply say this is not a perfect binary tree. Similarly, for this example, these 3 are leaf nodes, but it is not having at the last level, and it is not also having 2 nodes. So we can say that this is also not a perfect binary tree. Okay, so with this we have completed the 3 types of binary trees, which are very important and mostly asked in coding rounds. Okay, so now the last thing, we have some properties about perfect binary tree. So here we let that if a height of a perfect binary tree is h, so we can find out the total number of nodes by this formula, that is 2 raised to h plus 1 minus 1, and also the total leaf nodes in that perfect binary tree, that is 2 raised to h. So this is a shortcut formula to find out the total nodes and total leaf nodes. So with this I end this video, and we'll discuss more in depth regarding other topics and solve some questions in further videos. Thank you.